This is a little vodcast I'm making for my AP Physics students involving the analysis of this situation, which shows 3 blocks on a frictionless surface. We have a 42 Newton force pulling a 3 kilogram block to the right. The 3 kilogram block is attached by a massless cord of unknown tension T to a 1 kilogram block, which is in turn pushing a 2 kilogram block in front of it. We're asked to find the acceleration of the 3 kilogram block, the tension in the cord that joins the 3 kilogram block to the 1 kilogram block, and the force on the 2 kilogram block from the 1 kilogram block. One way to find the acceleration of the system is to first say that you don't actually care what the system is. It could be whatever. All you know is that it has got a mass of 6 kilograms and that something outside the system is pulling on it with a 42 Newton force. If you visualize it this way, the internal structure of the system becomes less of a distraction. Since the 42 Newton force is the only external force acting on the system, it is the net force. So we can set up our relationship for Newton's second law, which is in this form: acceleration equals F net over m, and sub in 42 newtons and 6 kilograms to get a mass or an acceleration of the system of 7 meters per second. At this point, I would pause the video if I were you and meditate on a way of how you could find the tension T of the cord that connects the 3 kilogram block to the 1 kilogram block. A profitable way to analyze the situation to find T is to just visualize the 1 and 2 kilogram blocks as a system and ask, what are the things external to this new system that are interacting with it? In this case, the only external force interacting with our system is the cord of tension T. And so we know that there's only one force. The system has a mass of 3 kilograms, and it's accelerating at a rate of 7 meters per second. Having visualized our system, we can now toss some information into our relationship for Newton's second law. Again, we have the acceleration is equal to the net force divided by the mass, and here we have the net force is an unknown value T. The mass is 3 kilograms, and the acceleration is 7 meters per second squared. Do this math, and you find an F net of 21 newtons, which is your tension T. At this point, I would stop the video and think of a way that you can answer the last part of the question, which was finding the force on the 2 kilogram block from the 1 kilogram block. If it would help you to imagine yourself as a member of European royalty, you can also do that. Even though the problem asks for us to determine the force on the 2 kilogram block, here's a diagram of the forces acting on the 1 kilogram block. First, we have the 21 Newton force that we solved for just a second ago. That's T. And pointing to the left, we have the force from the 2 kilogram block on the 1 kilogram block. I've drawn the leftward vector shorter because since the block is accelerating to the right, the net force to the right has got to be larger. The other two forces acting on this block are the weight, which is equal to the mass times the gravitational field strength, and also the normal force, which is supporting the block from the surface. We can use this visualization to set up a system of equations that describe the forces on the 1 kilogram block. First, we have the vertical direction. The sum of the forces in the vertical direction is 0 because the normal force is canceled out by the weight. In the x direction, it's more interesting. We have sum of the forces in the x direction is equal to the tension minus the force of the 2 kilogram block on the 1 kilogram block equal to mass times acceleration. So we have the 21 Newton tension minus this unknown force of 2 kilogram block on 1 kilogram block equal to 1 kilogram, which is the mass of this block that we drew the force diagram for, times its acceleration of 7 meters per second squared. If you do this math, you find that the force of the 2 kilogram block on the 1 kilogram block is equal to 14 newtons. And since the third law says that the force of object A on object B is the same as B on A, that means the force of the 1 kilogram block on the 2 kilogram block is also 14 newtons. And that is exactly what we want.